Hello and welcome to the ZetaChain Google Hackathon. My name is Dennis and I will be hosting this workshop. This is very exciting because we have two awesome technologies and projects working on these technologies. ZetaChain focusing, of course, on interoperability and blockchain technology, and Google on AI. And we want to give you the best tools to you builders to make awesome projects that leverage both AI, use Gemini to build tools to kind of create very quickly awesome things with all the tools that Gemini provides, and as well as, of course, ZetaChain, the platform for universal apps. Without further ado, I want to jump straight to the code, to the projects, just to give you as much useful information as possible. We're going to have more workshops like this, but hopefully the introductory workshop gives you good foundation so that you can start building right away without wasting any of your time on getting up to speed and all that. So let's get into it. Okay, so the first place you probably want to start is most likely the docs, right? As usual, go to zetachain.com/docs. We have a lot of useful information here. And I think for those who are not familiar with ZetaChain, who are new to the interoperability space, I think it would be helpful for you to kind of learn about what ZetaChain even is, right, from very high level. So ZetaChain is a blockchain that is a platform for universal apps. Now, what this means is, in a nutshell, you create a smart contract, ZetaChain EVM compatible. You write a smart contract in Solidity, you deploy it to ZetaChain, and it can be called by users and contracts from any chain connected to ZetaChain, which automatically means your application is cross-chain by default, right? You deploy a single contract. You don't have to deploy it on several chains. You just deploy it on ZetaChain, and users from chains like Ethereum, Base, Polygon, Solana, Sui, Ton, Bitcoin can all call your application and send tokens to it, and your application in turn can make outgoing calls. And we're going to talk more about this, but just so that you kind of get an idea of how easy or maybe how hard it is to build universal apps, here is one. And it's very simple, right? It's just one contract, one function called on call, and that's it, right? So it can be as simple as this. Doesn't do anything, but it gives you a general idea that it's really just it could be a simple contract, and that's it, all in a single file. But the cool thing is not the file itself for the contract, but like how it works with connected chains, because that's the main feature of ZetaChain, right? That's the reason why developers deploy contract on ZetaChain and not on other chains, is because you get this interoperability out of the box. So let's take Ethereum as an example here. You have Ethereum on the left-hand side, a ZetaChain on the right, and you deployed a universal app on ZetaChain and implemented the on-call function. And let's say it's just emits an event, right? That's it. It just says whatever the message was transferred to it. And users on Ethereum can very easily send data and tokens to that contract. So a user initiates a transaction on Ethereum, and they interact with a contract we call a gateway. So every chain has a gateway contract or a gateway address, like on Bitcoin. And this acts as a single entry point for users to be able to interact with these universal apps. So all universal apps are called from the same gateway. You don't get your own gateway. You use the same contract, and users can execute functions on this gateway. And one of them is deposit and call. So you have a function called deposit, you have a function called call, and a deposit and call which combines both. So deposit, as the name suggests, just transfers tokens without executing any code. All right, it's useful if you just want to transfer some assets from a connected chain to ZetaChain. You can deposit some ETH, and when the asset is deposited, it appears on ZetaChain as ZRC20 ETH. And this is basically just ZetaChain's way of accounting for these tokens transferred. So what happens really under the hood is ETH gets locked in the custody of ZetaChain validators. So it's all decentralized, right? ZetaChain is a proof of stake blockchain, has a validator set, and these validators, a subset of these validators, secures a custody on each connected chain. And that's where the ETH goes to, right? So ETH gets locked, and the corresponding amount of ETH gets minted on ZetaChain in ZRC20 tokens. ZRC is basically like ERC, except it has one additional function, basically, which lets you withdraw tokens back. So any holder of ZRC20 ETH can just call withdraw function or press a button, and the ZRC20 ETH goes back to the chain from which it was originally transferred as native asset. And that's actually one of the cool things about ZetaChain, is that we're trying to use native assets as much as possible. We believe that it's user prefer this way, right? They want to hold native USDC. They don't want ZetaChain's wrapped USDC on Ethereum, right? That's why we don't have ZetaChain Bitcoin on Base, that sort of thing. We have wrapped versions on ZetaChain just so that your contracts can essentially manage these assets on connected chains, but execute logic on ZetaChain. But at the end of the day, every chain has this custody that accepts and releases native assets. And this is really powerful because it makes transfer of native assets very easy. So we covered deposit. Then we have a command call, a function call. So call just takes data, a message, and transfers it to ZetaChain, relays this message to ZetaChain, to a specific universal app that you've chosen, and executes the onCall function and passes the message to it. So you can see here, right? The onCall function has ZRC20, which is the address of the asset that has been deposited. And there is an amount of tokens that has been deposited and a message. And message can contain any kind of bytes, any kind of data you want as bytes. And this is mostly how you call your universal app. You just pass call data to this inside this message and interpret it inside the contract. So this is really powerful because it lets you build things like this. Let me see if I can kind of expand this a bit. Maybe you can even open it. Okay, so here we have, okay, let me clear the screen. Don't think you can see it, but okay, here we go. So we have Ethereum, ZetaChain, and another chain, and universal apps let you build applications like this. I mean, this is simplified, of course. one of the simplest examples you can have, but still demonstrates the power of this approach. So basically, you have same thing, Ethereum, and a user passes some ETH, and inside the message they specify what token they want to get. So this is a swap contract, a contract that implements universal swap, so to speak. And a user from Ethereum wants to swap some ETH for BNB. So what they do is they call gateway's function deposit and call, pass ETH, specify the token that they want to receive. You can do this by providing a zRC20 address, which uniquely identifies each asset that ZetaChain supports natively. And then the gateway relays this information to ZetaChain, right? So the way it happens under the hood is we have a network of validators. So ZetaChain is a proof-of-stake blockchain with a set of validators, and a subset of these validators observe all connected chains. And when they see gateway emit an event, they vote on a transaction, and if the vote passes, if they all agree that this transaction actually happened, that funds got locked and the message was transferred, then they, through TSS and PC, they sign, well, actually, they do it on the other way around, but when a message is coming in, they vote, and if the vote passes, the blockchain, the ZetaChain, automatically executes the contract that you want. So you specified the contract you want to call, which is the universal swap. And what happens then is zRC20 ETH got minted, deposited into your contract, and on call is executed. So there's some swap logic. So ZetaChain has different liquidity pools you can use. And when the swap is processed, your zRC20 ETH got swapped into zRC20 BNB, and the contract automatically executed withdraw and call, which is one of the functions available on the ZetaChain gateway. So if gateway on Ethereum has deposit and call and deposit, ZetaChain's gateway has withdraw and call and withdraw to go the other way, right, from ZetaChain to a connected chain. Those tokens are withdrawn with an instruction to transfer it to another user, right, to the recipient. So it could be an EOA on the BNB chain, or it can even be a contract, like in this case, we're not only withdrawing, but we're making a withdraw and call to withdraw BNB into a contract and then execute the logic of this contract. So it could be another DEX that swaps into another token on BNB. So this is really powerful because a user just needed to sign one transaction on the chain that they're already on. So it could have been any other connected chain. Ethereum is just an example. So a user just signed one transaction, transferred the assets that they already have, in this case ETH, and a bunch of steps got executed automatically without user interaction. And in the result, some other user on BNB received some tokens, right, after this whole thing got processed. So the user didn't need to install any kind of specific wallet or know about ZetaChain. All of this happens completely transparently from the user's point of view. And what's important is that the gas is also handled automatically. So user doesn't need to have account on BNB chain or have tokens for gas on the destination chain, for example. And they don't even need to have tokens or their contract tokens on ZetaChain to pay for the execution, because all incoming calls are their users are not charged, contracts are not charged with a gas fee. And when an outgoing call is made, like this withdrawn call, it's on the contract to actually swap a fraction of the incoming token, for example, to cover the withdrawal fee, which is basically the fee on the destination chain. So if the chain is if it's not expensive to broadcast transactions on that chain, the fee is pretty low. It's a bit higher if you're making a withdrawal to Ethereum, but it's on the contract to actually provision the tokens. And you can go about this in different ways. The simplest one is when tokens are transferred, you take a small fraction, the required fraction of it, and swap it into a 0c20 version of the gas asset of the destination chain, and the gateway burns it. And then validators essentially execute this transaction on the BNB chain on your behalf. And here, validators actually do participate in a TSS ceremony to sign and broadcast a transaction on your behalf from the gateway to the destination contract. And tokens are released from validators' custody. And the reason why there are any tokens on the BNB chain, that's a very common question. Like, how do we know that there are even tokens on the BNB side? Like, we didn't deposit them, we just sent some ETH. How do we know BNB is there? Well, if there was no BNB, like if there was no BNB on the BNB chain in the custody, then you wouldn't be able to swap the tokens in the first place. So the simple fact that you were able to swap tokens on ZetaChain means that there is liquidity, BNB liquidity on ZetaChain, and that means someone has deposited tokens from the destination chain. Otherwise, you wouldn't be able to swap. So, and of course, you can imagine that this logic can be kind of extended to any sort of application. So swap is just a simple example, but you can build all sorts of cool things with lending, with NFTs, with transferring data and across chains to like execute custom logic on Solana when triggered from Bitcoin and then going to Sui, and all this crazy stuff can be implemented pretty easily on ZetaChain. And yeah, super excited to share all this with you builders. So, okay, let's move on. Going back to the docs, I think the next step is to actually go into, well, we covered universal apps quite a bit. ZetaChain has Bitcoin support, one of the few solutions for that actually integrate with Bitcoin. And we covered gas abstraction already. Your contract takes care of that, has all the tools for this. And I think, I mean, you can read this later, but yeah, ZetaChain essentially provides very sophisticated but easy to use mechanisms for building these universal apps. And your contract, you can think of your contract as a cross-chain orchestration contract, right? It accepts calls and tokens from one chain. It does something, maybe a user on Bitcoin transfers tokens on ZetaChain, buys an NFT, then lends it on Solana and goes back and does something else. So a lot of room for creativity. And of course, native tokens, right? Every chain has custody of native assets, so you can, what you get on the destination chain is not ZetaChain wrapped version of that asset, but actually USDT, USDC, ETH, Pepe, what have you, in a native format, which is really nice. And yeah, it's like you could see this in this diagram that's like we have some chains around ZetaChain, and the reason why it's this way is because with ZetaChain, we adopted the hub and spoke model where we have ZetaChain as the hub and chains connected through spokes, and all calls go through ZetaChain. So if you want to make a call from Ethereum to Solana, you can do this, but the call will first go from Ethereum to ZetaChain into your contract, which will then route this call to Solana. In terms of time it takes to process this, it doesn't impact the time all that much because ZetaChain is pretty fast. I think it's like 3-second blocks, and we're working on making it even faster. But what you get is something that you don't really get with solutions for cross-chain messaging, because the complexity of the system grows linearly with more chains. As more chains are added, the number of spokes just grows by one, right? New chain is added, one spoke, and you really have to worry about the contract you have on ZetaChain. You might have some contracts on connected chains for sure. Some applications require that, but at the end of the day, most of the logic will be most likely in your ZetaChain universal contract. And it's much easier to keep track of all the calls if you can kind of intercept them on ZetaChain. So it's not about connections between all these chains, right? Imagine you have, I don't know, 5, 7 chains. It would be pretty complicated to manage the complexity associated with all these connections. With ZetaChain is just 7 connections and a single orchestrator contract that you build. Okay, moving on. So let's take a look at, I mentioned some of the chains, but let's take a look at the chains that ZetaChain is currently connected to. And you can see it's Base, BNB, Bitcoin, Arbitrum, Avalanche, Sui, Ton, Ethereum, Polygon, Solana. Those are on mainnet. And it's actually the same list on testnet. And you can read about the gateway in detail in these sections. So every chain has a section dedicated to the gateway, because this is pretty much like the main API you would be using. And it's pretty straightforward, right? All of them, like at least on the EVM side, it's just a function that accepts some parameters. That's it. Everything else is abstracted away from you as a developer. Specifically, the cross-chain logic, you don't really have to deal with that in your contract. You just work with contract calls, right? So if cross-chain logic happens, if someone makes a deposit and call, your on-call function gets executed, right? There is no cross-chain specific things to worry about, really. Okay, and moving on, I think the next step would be for you to actually go inside the first universal app tutorial. It's a good starting point for you to kind of understand better how these apps are actually built and familiar diagram. And the first step is actually to use ZetaChain CLI. So we have a very convenient tool called ZetaChain CLI. Let me switch to my terminal. Okay, so if you type, I'm assuming you have a Unix-like system. So the prerequisite for developing on ZetaChain, for a good developer experience, actually is Node.js and Foundry. And you might need some other tools like JQ just for convenience. And if you want to build on Solana, then Solana CLI, Sui CLI, that sort of thing. And most of the functionality is actually encapsulated in a single CLI called ZetaChain. So you can npm install ZetaChain. I already have it installed. and you can check the version. And we're trying to put all the good functionality in the CLI, so you can check it out. ZetaChain help. Have all these commands where you can create new contracts, you can query the chain, and you can, of course, make calls from all these connected chains to ZetaChain. And then there's LocalNet, and I'm going to talk about this a bit later. But right now you can, let's see if I have hello here. Yeah, I do have. Let's clean this up. And the first thing you would do is you would execute ZetaChain new project hello, and it just essentially clones the repository, and you get the contract there. It's very convenient, and you can see all the examples we have. And so the hello example, NFT, swap, token. I'm gonna cover some of them. What I'm gonna do now is actually switch to the examples repo. You can just clone that as well. And in the examples repo, we have, well, the hello example that you would get if you type ZetaChain new. And it's a super simple example. It's just a contract that just emits an event when a message is transferred to it from a connected chain. And I strongly recommend you go through the tutorial because it covers some of the aspects of how to actually get it up and running. But I'm going to demo it right now. So the first thing you probably want to do is install dependency with Yarn, and there are some Solidity dependencies, and we use Soldier for that. So forge Soldier update to get the latest dependencies. And let's go over the contract again. So it inherits from universal contract, and it has a constructor which takes a gateway and stays in a variable, because for most of the scenarios you probably want to have a gateway on hand to make outgoing calls. And you also need this for a only gateway modifier to ensure that on call is only executed by the gateway. In the next versions, we're gonna remove some of this boilerplate, but for now, you need to have a modifier to ensure that on call it can only be executed by the gateway. Otherwise, anyone can pretend that they've deposited ZRC20, some ZRC20 tokens when they didn't. Don't want that. And the logic is super simple. It's just decoding a message as a string and emitting an event. So that's all there is. There's no additional contract code. I think it's really good for like hello world kind of introductory example. Let's try actually building it. So we can deploy it on testnet for sure, but what I wanted to do is I want to show you LocalNet, which is a very handy tool that you can use to essentially run ZetaChain and most of the connected chains locally on your machine without having to interface with testnet. Testnets acquire tokens, and it's just much faster. So we're going to try that. So we have ZetaChain pre-installed globally, but we also have it in the project. So you can use npx ZetaChain to use the version that is installed in this project. Let's check the version, make sure it's the latest one. It looks like it is. So ZetaChain has LocalNet set of commands. And we're going to use the start command to start LocalNet. So what it does is it launches Anvil, so it needs Foundry to be installed. It's going to throw an error if it doesn't find Foundry CLI tools like Anvil and Cast. And it starts an instance of Anvil, deploys ZetaChain gateway contracts, deploys contracts for Ethereum for like connected chains. So it simulates these chains on a single Anvil instance, and we can see all the protocol contracts here, as well as the private key. I mean, it's standard private key for Anvil. Nothing. It doesn't secure any real funds, sure. So you can see that contracts on 3 chains have been deployed. Have gateway contract on ZetaChain, gateway contract on Ethereum and BNB. And you can deploy contracts, universal contracts on ZetaChain here in this environment and make calls to it. So let's do that. So what I'm gonna do next is actually use Forge to build the contract. Let me switch to the hello directory and Forge build. You can use npx, but we're kind of switching to Forge. But yeah, feel free to use any compile tool you want. I actually have hard hat config here, so npx hard hat compile should do the trick. And eventually it's going to compile. Okay, and compile the contract. And what we need next is we want to deploy this contract to our local net chain. So I'm just going to cheat a bit and copy some of the code here and then kind of show you what this is. So basically, we're using Forge create to deploy the contract, and it needs some parameters. Specifically, the constructor variable is constructor parameter is gateway address. So we need gateway address, needs a private key, and we specify our PCR URL as the local host. So let's just fill out the blanks here. You can programmatically get this from .ZetaChain directory in your home directory, but we can just copy and paste this stuff from here. So instead of ZetaChain gateway, we're going to do this. And in fact, we're actually going to need it. So we might as well just specify ZetaChain gateway ZetaChain. And the private key is going to be this. So private key. And now we can just execute this command. So we deployed the contract on ZetaChain localnet. And now let's actually make a call. So let's use ZetaChain CLI for that. We have a namespace called EVM, which makes easy to make calls from connected EVM chains. And let's use the call command. And now we just need to specify the RPC, which is by default localhost. Let's actually look at the call options. So the ones that we do need to specify is gateway, which is so that the command knows which chain we're calling this from. Then we need a receiver, because if you remember from the docs, this is one of the arguments that the call method actually requires. So we're passing the universal contract address as the receiver. We need private key, have a variable for that. And then we need to specify the data. So data can be anything, but it's very convenient to just pass it as ABI encoded data. And we have some helpers for that. So we have a types flag where you can specify a list of types. In our case, it's just going to be a string, and values, which is going to be hello. And this just will take the data and encode it using ABI and put it in the payload. So let's execute this command, check the details. It's going to send hello as a string from our address to our universal contract address on ZetaChain, and let's see what happens. So all of this is running locally, so we didn't need testnet tokens or anything. You can see that on Ethereum gateway was called, and we then it then emitted an event. The protocol contracts essentially, since this is all simulated on the same chain locally, the protocol contracts observed this event, and ZetaChain called a contract with this context. So we can see that the context matches here, right? We got chain ID, sender information, the ERC20 address actually matches the ETH from Ethereum, because that's what you get, right? We actually didn't deposit anything. It was just a call command, but it still specifies the gas asset of the chain from which it was deposited, from which the call was made. So we could have used deposit and call and specify and transferred USDC. Then it would shown this ERC20 address that corresponds to USDC, but it's gas asset and ABI encoded data, which is hello. And then our contract emitted an event from on call, and yeah, basically that's, in a nutshell, that's how it works. Very straightforward. You get a contract, right? You deploy a contract, and then you can call it from a connected chain very easily. And we can actually do it the other way around. We don't have a contract to call in Ethereum, but we can probably make a withdrawal. So let's try doing that. So npx ZetaChain. Well, we can just say Z and then withdraw. So we made an incoming call, and now we're just doing an outgoing call. And for that, we need to also specify the RPC gateway receiver. Let's just copy and paste that and just update. So the gateway is going to be a gateway on ZetaChain. The receiver will be our own address, not the contract, but ourselves. We want to withdraw some tokens to ourselves. And withdraw also needs an amount, pass 0.1, and ERC20. So it needs to know which token we're withdrawing. So let's withdraw some ETH. The transaction looks good. Let's see if it works. It did. So on ZetaChain, gateway emitted a withdrawal event, and on Ethereum, we transferred some gas tokens from the TSS address, which is the custody essentially, to the receiver. And we can, of course, use BNB, USDC on BNB. So here we actually transferred USDC to the BNB chain. There's some formatting errors, but at the end of the day, you can see that the tokens have been transferred from the custody to the receiver. And you can, of course, launch this with Solana support, SUI. So LocalNet is really powerful this way, where you can say start help. You can see that it has support for Ton, Solana, and SUI. By default, doesn't launch anything other than EVM chains for simplicity, but you can very quickly get up and running and deploy, run it with SUI and simulate calls from SUI to Universal Apps or from Solana to Universal Apps. Okay, so we covered LocalNets. If you want to learn more about it, you can go to our docs, and there is a section dedicated to LocalNet. And of course, there are docs for the inside the CLI. You can use it as well. Okay, moving on. what we can do next is, I guess, we can deploy it on a real testnet. Why not? By doing that. So we've already compiled the contract, and what we need is we need to deploy it on ZetaChain testnet. So I actually have this command already, just so that we don't spend time writing it down, but we're using a ZetaChain testnet RPC URL here instead of localnet, and we're passing the actual ZetaChain gateway on testnet. So this should deploy the contract. Okay, echo universal. Okay, so this is our contract. We've deployed it on ZetaChain. Now we need to make a call to it. So the process is exactly the same. We're using ZetaChain CLI to make an EVM call, and here we're just specifying the chain ID. In our case, that's base Sepolia, and the receiver is our universal contract private key, and we're doing the same thing. We're sending just a string hello. Okay, so this is a transaction we broadcasted on base, which will call a universal contract on ZetaChain. We also have a very handy tool for querying cross-chain transactions by hash. So you can use query cctx hash, and this will start polling for transactions. Not polling, but it's going to look it up on connected chains, in this case base. And as soon as this transaction is observed by ZetaChain, it will show the whole all of the information and the whole path that this cross-chain transaction takes. In our case, that's just a call from base to ZetaChain. And let's give it some time because it's actually running on real testnet. So every transaction that is observed before it's observed by ZetaChain, oh, here we go. It was actually very fast, right? So from base to ZetaChain, and yeah, it was successfully called. And we can check these hashes actually on explorers. So let me open up a browser. Okay, so what we can do now is take these transaction hashes and look them up on base first, because that's where the initial transaction was broadcasted. So here's my address, and it's actually making a call to base gateway. It ends in 4995 on most EVM chains, and we can decode the call and actually see for ourselves what's going on under the hood. So there is a receiver which matches the contract that we've deployed, and let's actually copy it. And the payload just contains the hello world, not hello world, but hello string. And there are some revert options, which we didn't cover, but essentially revert option struct is a way for you to specify, okay, I'm not sharing my screen. I'm so sorry about that. Okay, let's go back again. So basically, I opened the transaction hash on the base scan explorer. It's the transaction that was broadcasted that contains a call to universal contract, and we are now looking into the parameters that were passed to the gateway call function. So receiver payload and now revert options. So revert options tells the gateway and ZetaChain in general how to handle scenarios where the call is unsuccessful. So let's say your contract throws an error, and we can actually simulate that by inserting a revert, and you can see how this changes things. So ZetaChain supports revert scenarios where universal contracts throws an error, and what happens then depends on the values in the revert option struct. So it's recommended that you specify revert address because that's the address that will be called on the connected chain if universal contract fails. So here we're just specifying our own, I guess, our own address. But in this case, it doesn't matter. The contract will always succeed. Call and revert tells gateway whether to make a call when the universal contract reverts or just transfer assets. And a board address specifies which contract on ZetaChain to call if revert cannot be completed, right? So yes, it could be a bit confusing, but when you start using it, you kind of understand the flow better. Revert message is the message that gets passed to the contract that is executed when basically to the revert address. So to understand this a bit better, let me try to use an example from what is ZetaChain? No. Let's use this example. So if the call from Ethereum to ZetaChain fails, I mean, not the call itself, but the universal app throws a revert, right? Throws an error and reverts. Then ZetaChain will try to make a call back to the chain from which the call was made in the first place, in this case, Ethereum. And it will take the amount that was deposited, right? In this case, 6 ETH. It will take a fraction of that, swap it into the gas asset of the chain from which the call was made. So that's Ethereum. Burn this small amount and make a revert transaction back to Ethereum. And depending on the revert option struct, it will either, if the call and revert is false, then it will try to transfer the tokens, so 6 ETH minus the gas fee, to the revert address. So if call and revert is false, then it will transfer the tokens to the revert address, and that's it. If call and revert is true, then means you probably specified a contract address inside the revert address, then it will execute the onRevert function of that contract, and it will specify this onRevert gas limit as such. In this case, 200K gas. It will pass the revert message to this contract, and that's how you can handle reverse scenarios. So, for example, if you're transferring an asset and something failed inside your universal contract, it will go back and it will execute onRevert of the specified contract, and then you will probably transfer the funds back to the original sender, and the information about it is going to be inside the onRevert message. So Ethereum to ZetaChain, then back to Ethereum. And if you're making a call from ZetaChain to BNB, then what happens is you make a call, something goes wrong on the BNB chain, it will always make a revert back to ZetaChain because incoming transactions are gasless, essentially. So you can specify which contract you want to call inside the revert address, and it will call that contract's onRevert function, and you can handle the call. In some more sophisticated examples, it will actually, inside on revert, it will make a call to another chain. So let's say we have NFT transfers. We didn't cover this, but we actually have a solution for universal NFTs, where you have an NFT on Ethereum, BNB chain. Users can transfer them. So in this case, the NFT goes through ZetaChain to BNB chain, but if it failed to be transferred, it will go back to ZetaChain and then back to Ethereum, because inside on revert, we can also make withdraw and call. So this is a really powerful mechanism, and maybe this is a good segue to actually universal assets. So we have pre-built solutions basically for some of the common problems that developers have, or like common scenarios that developers face, and specifically NFTs and fungible tokens. So in this example, not example, but basically universal NFT is an ERC-721 contract extended with cross-chain capabilities. And you deploy this contract on Ethereum, ZetaChain, and BNB, or any other, I mean, in this example, these chains, but you can also deploy it on any other connected EVM chain. And users can move these NFTs between these chains. And this is pre-built. So if you are building an NFT app, I encourage you to check it out. It's very easy. Just use the CLI to create a new project and deploy it. Very straightforward. Maybe we'll cover this in a separate workshop because it's going to take a bit more time, but it's super simple, right? It's just deploying contracts, telling them about each other, minting an NFT, and then transferring it. And it works exactly the same way for fungible tokens as well. So this is cool if you have an idea for a token that has to be on all these EVM chains and users can move them around, and maybe you build an application that does something with these tokens. So all of this is pre-built, so you can use that. And speaking of pre-built things, I mentioned that the way you build on ZetaChain is you deploy universal contracts, right? But if you already have contracts, you can check out our latest addition to the pre-built family of projects, which is messaging, where you can make calls between EVM chains without deploying anything on ZetaChain. Could be a good intro for you if you're familiar with other cross-chain messaging solutions, where you, instead of deploying a contract on a chain like ZetaChain, you deploy it on Ethereum Base, Polygon, Arbitrum, and then you connect all of them and you can send messages between them. So it's also a good example of how you can build something like this yourself. You can take the messaging example and extend it and build an application on top of that. So yeah, do check it out. Moving back to what we were talking about, which was this call that we made from Base, right? So this is the original call, and the last thing I'll show is actually the contract on ZetaChain. So ZetaChain testnet, use Block Scout for this. Open the contract. So this is the contract that we called, that we deployed, the hello world contract, and inside the logs we can see that it emitted an event with the hello string. And you can also, if you go to the terminal output and copy the transaction hash, you will see the transaction that triggered this. So it on your behalf, it called the gateway, ZetaChain gateway, and made the call to Universal App. But yeah, you can make a call again, and you'll see one more event in the logs. And this is kind of how you build these universal contracts. Like the underlying principles stay the same. You write a Solidity contract, deploy it on ZetaChain, implement the on-call function, and use the gateway whenever you need to make an outgoing call. Okay, so I think we covered a lot of grounds in this workshop. I hope it was useful for you as a developer. So I strongly recommend you go into the docs and kind of start with the simple example. It really takes just a few minutes, as I showed earlier, to deploy Hello World. You can do this on local nets, very convenient, very easy to test your application to see how it works. Personally, I develop all the things on local net first, just because it's so fast and I don't need to wait for the transaction to be processed. And yeah, you can deploy this on testnet next to see how it actually works, see the events for yourself, and then expand into something more functional. We also have a swap tutorial, which is a more sophisticated cross-chain swap application. It's just like 200 lines of code, maybe a bit more. You implement a contract that performs cross-chain swaps in all the directions, including Bitcoin, Solana. It's compatible with all the chains we support, and it routes tokens to the chain. Like you specify one USDC on Arbitrum, and here's BTC, and it's going to swap the tokens and withdraw the tokens to the destination chain. So if you're building something like a DEX, I recommend checking out the swap example. So, okay, I think we're at time now. I wanted to keep it under 1 hour just so that it's a bit easier to kind of digest and understand. We're going to have more workshops. If you have questions, and I'm sure as a developer you will have questions about uh, all this cross-chain stuff, all the tools we have, how to build stuff, please go to our Discord server, Dev General channel. Very happy to answer all your questions there. If you're want to know how to like interact with ZetaChain from Bitcoin using inscriptions, we have tools for that. We're going to cover this in our next workshop, most likely. If you're building a front end, we also have tools for that. So yeah, again, I welcome everyone to the hackathon. It's very exciting. Please use the tools that we've built. Use Gemini to quickly start and build your next application on ZetaChain. All the tools are there. All the resources are there. Is just waiting for you to come with the next big thing idea and implement it. Very, very excited to see what you guys build, and see you in the next ones. Goodbye.